In this lesson, we're going to be talking about topic 4.4, which is complex numbers. We're going to be answering the essential question, what is a complex number and how can you add, subtract, and multiply complex numbers? And your I can statement is I can add, subtract, and multiply complex numbers. We're going to start by exploring operations that involve complex numbers. So remember, a complex number is a number that involves, it could be part of the real system, but it also could involve the imaginary numbers as well. So we're going to start by just adding these two binomials up. So we're going to say 3 plus 4x plus 2 minus x. All right, so that looks like something we've been doing since probably before Algebra 1. So I'm going to add my like terms together. So I'm seeing 4x and negative x, and I'm saying, think that's 3x, yes. And then I'm seeing 3 plus 2, which is 5, which we could write like that, or we could write it like this. Either way, there's both correct. In the next one, we are supposed to subtract 2x, my 2 minus x from 3 plus 4x. So I think that what they're meaning is 3 plus 4x, subtract that. So this is subtracted from this. So minus, I always put a parentheses when I do a minus sign, 2 minus x. And the next thing I need to do is distribute that minus sign. So 3 plus 4x minus 2 plus x. 3 and negative 2 would be positive 1. And 4x and positive x would be 5x. And this last one says that it wants us to multiply these binomials together. So we've got 3 plus 4x times 2 minus x. Well, we've been working on that for a while. We know that we have to FOIL that. Or I could get out the box if I wanted to. We were working with the box. We could do that. So I'm going to FOIL. So 3 times 2 is 6. 3 times negative x is negative 3x. 4x times 2 would be 8x, and 4x times negative x is negative 4x squared. And then I would want to combine like terms in the middle, so you get 6 plus 5x minus 4x squared. So now, the question is, why did we do all of this stuff? Because this was no different than what we've been learning for a while now. So in step A, you found that 3x plus 4x plus 2x minus x equals 5x, 5 plus 3x. Suppose the x is going to equal an I instead. What would we get? So basically they're saying, hey, replace the x's with i's instead. So we would end up with the 3 plus 4i plus 2 minus I, which again, we would just combine like terms. So 3 plus 2 is 5. 4i minus I is 3i. In step B, we were supposed to subtract the two things. So I'm going to just go ahead. There's an obvious typo right here. It was supposed to be a subtract sign. So we're going to go ahead and replace those with I. So 3 plus 4i. I'm going to distribute that negative in while we're doing it. So negative 2 minus I, because I'm replacing the x's with i's. So that means I'm going to get 1, and then 4i minus I would be 3i. Somehow we're getting something. Minus a negative would make that positive I. There we go. So plus 5i. All right, and then in step C, you found that 3x plus 4x, we found this when we multiplied it out. Well, guess what? Just like the others, we're going to replace those with i's, but there's a little bit of a catch on this one. So we've got 3 plus 4i times 2 minus I. Let's FOIL it out. So 3 times 2 is 6. 3 times negative I would be negative 3i. 4i times 2 would be positive 8i. 4i times negative I would be negative 4i squared. So this works like normal, 6 minus plus 5i. The catch comes in I squared, because remember we learned in one of our other lessons that I squared is equal to -1. So I have to replace that with a -1, which means that I get 6 plus 5i plus 4, which is going to mean that I'm going to end up with 10 plus 5i. So when we're in the complex number system, we should only have our real unit and our imaginary unit. We don't have any squareds, any cubes, any fourth powers, and so on.